Hi there, welcome to this module on network forensics. We are continuing with where we left off in the last session. In the last session, we were looking at DHCP servers and the forensic value that we obtain from the DHCP servers. We move on to the next part where we look at name servers. Okay, name servers usually called as domain name servers, domain name systems. Okay, they convert the IP address to host names and vice versa, host names to IP address. Okay, so the idea with domain name system is that instead of having numerics as IP address, we would like to have names which represent something. For example, instead of having 192.168.0.5, we can say that this is some xxx.com, where xxx could be some company name. For example, we have nptel.ac.in, which is the domain name of nptel. Now, the name servers are actually hierarchical in nature, and as shown in the figure on the right hand side, we can see how a name server works. Suppose I just want to find out the IP address of some domain name. What happens is that it sends it to the next level of domain name server. It tries to identify the domain name in the current cache, either in the switch or the router that you have. Usually it will be the routers. If the router does not act like a domain name server, then it goes to the next higher level domain name server, and if that does not address, then it goes to the next higher level domain name server, and the answer percolates all the way back down. What is the forensic value of these domain name servers? The first thing that you can look at is whether the domain name servers are configured to log the queries. That means if a machine attaches itself to a network and I want to go to a particular domain, I will type that, let us say http://www.somedomain.com or .go.in or whatever it is. Now, at this point of time, the request goes to the gateway, and gateway, if it is a domain name server, it just responds if it has the answer, otherwise it sends to the higher level. Now, any request, such request can be logged, okay, and so the connection attempts that are made from the internal to the external systems, for example, websites or SSH servers, secure shell servers or external mail servers, etc., can be got from the logs that are provided by the name servers. Okay, and this helps in actually creating a timeline of the suspect activity. Suppose I go to a website which I am not supposed to go, then if I type the website name, then what happens is that the logger of logs at what time I try to access that website. So, this gives a clue on at what time we try to attempt something. So, the next is the authentication servers. Okay. Usually, if you have a centralized authentication services, for example, a authentication server where you can log in and then the login credentials are validated, etc. Okay, usually many of the organizations have Active Directory or some LDAP based servers. Now, these servers actually authenticate the user whether they want to log into a machine or a network, etc. So, the advantage of these kind of this, along with say I mean you have some Radius, TechAx, those kind of servers. Along with these, okay, what you can do is you can log the authentication details. For example, if I want to log into my organization network, then I have a username and a password. So, where does this username and the password get validated? I mean, if I have thousands of machines, I can't have a local database where in the local machine I can't store my validation credentials. So, I just have to store it in a common directory services. So, this is exactly what the directory services provide. They also provide authentication, authorization, and sometimes and accounting also. So, all the three logs can be very useful. For example, if you unsuccessfully try to authenticate, it will be actually logged in the authentication servers, and if you try to use a brute force password attack, it will be logged in the authentication servers. As a practical example, if you actually connect to the internet website of some bank, let us say, you actually try to put your username and then try to give a password. Now, if you give a wrong password, if you see in many of the banks, they do not let you more than 2 or 3 attempts. I think 3 attempts is a standard that they allow. Now, after you fail in this 3 attempts, actually your account might get locked. Now, all these things are done with the help of a authentication server. So, on the right hand side, you can just see how an authentication server works. This is at a very high level. So, the authentication servers, the logs that is given by the authentication servers actually can give you a lot of information. For example, if you are working out of office hours, okay, and you are logging in from locations which are not authorized. For example, I mean you say I am on vacation, but I try to log in from some other location, okay, all these things can be logged, and this will help in forensics. Now, sometimes you are not allowed to have some kind of a privileged login. Say for example, kind of a root, you are not supposed to log in as root into any of the machines, but Eugen has logged in as root into many of the machines. So, this will also be logged by the authentication server, and sometimes I mean these are logged by the local servers also, that someone has tried to get root access, etc. Now, in this way the authentication servers provide a huge amount of forensic value with their log files. The next device that we are going to look at is the network intrusion detection and prevention system. So, now this is actually a security device, okay. So, this device was done exactly for the purpose of network forensics, okay, and these devices have very high processing capability also. So, these devices actually monitor real time traffic, and if they find any suspicious traffics or flow, okay, they actually raise an alarm and they can be configured. I mean all these things, okay, let us be clear, it is the work of the system administrator to configure these devices correctly. Many of the security lapses happen because the devices are not configured properly, or they provide some kind of a loophole, because almost all the organizations which supply these security devices also include patch as and when any of the attacks happen. Now, in many of the cases that has happened, the real problem with security was not that the patch or the fix was not available, it was actually that people did not upgrade those fixes. So, similarly here you can have any type of systems, you can have all technologies that is available, but if the human user finally fails to apply those technology, then the security loopholes occur. Okay, and especially this network intrusion and detection and prevention systems, actually what they work mostly based on some kind of pattern analysis and then packet filtering, etc. Usually what they do is you can actually configure these machines using command line. We will be looking at some of these commands later, but as this sessions, okay, the coming up sessions tells you, I mean how we in general do the forensics, I mean how we in general collect the data. Okay, and look at this, we are now looking mostly into software, but we will also later see that there are some software tools, I mean we are looking mostly into hardware, and we can also see that we will have some software tools which we can use that works along with this hardware to acquire all this information. See, sometimes this intrusion detection and prevention system can recover entire contents of network packets also. More often recovery is only source and destination IP address, and as I talked to you in the last class, mostly it will be about metadata, because storing all the data is extremely difficult unless the network investigator has clues that there is something really happening in the network. You do not want to store all the data that you want to trace, you just want to get those data that is very important for the incident, to establish the incident, okay, or to find out whether the incident has occurred. So, and that can mostly be recovered using the metadata that we have. The next security gadget, okay, which can provide you good amount of information is your firewall. Okay. Usually firewalls can provide deep packet inspection. So, what do I mean by deep packet inspection? I told you that intrusion prevention and detection systems actually look at the metadata, that means the headers and other information, whereas firewalls can actually go into the packet. It can, if possible, it can also find out what is the data that is being transferred. So, usually we again use firewalls to filter packets based on the source and destination IP addresses. It can also give you information on what are the encapsulated protocols, etc. The advantage of firewalls is that it provides a granular logging, whether you want a coarse granularity or a fine granularity, you can actually specify it in the firewalls, and the firewall logs you can use based on what is that where you are in the investigation phase. Okay. And firewalls also protect as a intrusion detection systems. Okay. The what you can do with firewall is that once I configure the firewall, it can log what are all the allowed or denied traffic flows, okay, and it can also log system configuration changes, errors and other events. So, the firewalls and intrusion detection systems together, actually these are the two critical components if you want to do network forensics or whatever it is. These are the two critical components which you have to look into very deeply to understand what has happened. Okay. This does not mean that the other components are not useful, but you have to give priority to especially this firewalls, application level server, web servers, okay, and application level firewalls, the network level firewalls, and of course web proxies, which we are going to see now. Okay. So, web proxies provide two functions. One is they obviously increase the performance of, or they lessen the time that is taken to visit a website. This it does by caching the frequently or most often visited web pages. One of the things you might happen is that suppose the web page on the server has changed and your web proxy has cached it, there is a possibility that there could be a difference in the web pages that you see. There you have to do something known as a forced resync of the web pages. Okay, but in general web proxies are very useful because they act like a doorway. Okay. When a person browses the web, okay, these web proxies serve as a doorway, therefore, we can put lot of security measures on the doorway to ensure that software, malignant software or whatever it is, does not get into the network. Okay. The advantage of web proxy is that it can log what are all the sites you are going, what are the activities that are happening in the HTTP packets, etc. You can inspect the packets and it can even filter the packets. Okay. So, what we can do is we can put some sort of filters so that it blocks certain websites. For example, many of the organizations block Facebook and Twitter during their official working hours, and all these things can be done with web proxies. Okay. And sometimes if you people usually bypass it. Okay. So, anyway, so the forensic value of web proxies is that the granular logs can be stored for a long period of time, and many of the proxies actually provide a beautiful visual report of what is the user's search pattern, etc. For example, if a user every day in the morning, whether he comes and looks into the Facebook first before he logs into the official servers, etc. Okay, all these things can be monitored. The other things that we can do is that it can even analyze whether the phishing emails successes are there, inappropriate web surfing habits. As I told you, web based malware, if there is anything, yes, these web proxies can ensure that you can block all those things or at least log all those things. The user usually looks at the contents of the cache that is stored in the web proxies. But anyway, since as I told you before, it provides a single point doorway or for the data traffic or the HTTP traffic to go out, you can actually log lot of information with these web proxies. And finally, we have these application servers. Okay, so, the application servers are database servers, the web server, the email, the chat server, the voice over IP or voicemail servers, etc. And these forensic value are very important because these actually store the end results, and if you look at this, there is a difference between the standard packet firewall and the application level firewall. So, if you look at what is happening is that, so if you look at non HTTP attack, then it, I mean we were showing it as an example here. So, if you look at non HTTP attack, it just gets bounced off by the standard packet firewall, whereas if it is a HTTP attack, then it gets bounced off by the web application firewall. So, this is actually two levels. You have one level where you filter almost all the packets, then if that escapes, okay, you can filter it using the web firewall. Anyway, so coming back to application servers, the logs of these application servers are very important. So, one question that arises is how much log data do I collect, okay, and how much do I preserve, and for what period do I preserve, okay. It depends on what country you are in. Many countries mandate that you should have it for about 10 years, etc. That means the amount of data with speed and the storage, etc., it will be massive. The next is the central log server. Usually, as I told you before, the use of the central log server is generally when I want to send all the logs to a particular location and then do some sort of analytics on this. Okay. So, what we do with the central log server is that you can combine event logs from many of the sources, okay, and you can just get this time stamped, okay, and correlated and analyzed automatically. So, this central log server will have massive data. Not only will it have massive data, you also have to have a lot of good algorithms to get correlation and analysis, as well as to some extent visualization, okay. And this, it all depends whether do you want to have a centralized logging or a decentralized logging, and only if the incident occurs then I collect all these data together. All these things are based on what your organization is planning to have as the vision, mission, or whatever it is, okay, or policy. Okay. So, coming back to forensic value of the central log servers. Okay. So, these central log servers actually are used to find out how a security lapse has happened and why it has happened, etc. Okay. And this usually should be replicated, because if a person who attacks a central log server almost can delete all the evidence that you save, okay. And sometimes the advantage of having a central log server is a router might not have enough memory or space to save all the logs. So, you just push many of those logs, not only router, any of the other devices that we have seen until now, you push these logs and then store it in a central log server, okay. And there are a lot of commercially available products which can provide complex forensics reports and graphical representations of data. So, this is more or less, I mean, you are going to have huge amount of data, and then you are going to analyze the data and then present the results, okay. So, this needs to be a very powerful server with large amount of storage if you are really looking at centralized logging. Okay, until now we have looked at what are the kind of hardware devices, and then we also looked at what is the forensic value that is provided by hardware devices. Let us briefly look at the Internet Protocol suite, okay. So, because when whatever security attacks happens, finally you will be looking at what happened to the protocols, okay. So, if the Internet Protocol, you will be able to identify from where the data, the attacker originated the data, etc. Okay. So, if you want to do network forensics, you need to completely understand the TCP/IP, including the options and the ports and then the data, etc. Okay, especially the header fields, okay. And the other point with Internet Protocol suite is that if you look at Internet Protocol on TCP and other protocols in TCP, IP, etc., they actually slice the packets and then sends the packets. Now, this it sends it via a common medium, okay. Different packets can traverse to the common medium. So, you should be able to identify, one, from which machines the packet originated, two, the flows, okay. Flows, a group of packets which arise from, say, the same machine and the same user, you can call it as a flow. So, you should be able to understand how flows can be segregated from packets, because many of these analyzers, packet analyzers, they actually dump all the packets, and you from the packets you should be able to capture using some kind of a filters, you will be able to capture the flows. Okay. One of the example, something has come up in the screen. What is that suddenly? Oh, okay. Okay, fine. So let me start. Let me start from this slide, Internet Protocol. Okay, until now we have seen lot of hardware devices that we are looking for forensic value. The most important among all these devices, you can attach all these devices, but then we need the Internet Protocol suite, we need to understand the Internet Protocol suite. The Internet Protocol suite is essentially the TCP IP and UDP. Okay. I mean, of course, there are other protocols also, but a forensic investigator must completely understand the key protocols that are used in the internet. Okay. For example, if you want to decrypt voice and things like that, you should have an understanding of SIP. Suppose you want to look at emails, then you should understand how SMTP works. Okay. And all these protocols run over TCP and IP, therefore, you should have a thorough understanding of TCP and IP. There are two things that you should know. One is the packet level analysis. Okay. Packet level analysis tells you, I mean, what are all the packets that went through a particular machine. Then there is this flow level analysis, where this flow level analysis tells you how the packets are related. Okay. So, some related packets becomes a flow, and so many of these software which look at dumping the packets and writing into a file while acquiring the packets, okay, acquiring the data. So, what these software do is that they just write everything to a file. Now, from this file we should be able to analyze through filtering what are all the flows, etc. Okay, and then dissect them. So, essentially you try to find out this belongs to this, these packets, this group of packets belong to this flow. Say for example, FTP, these group of packets belong to voice, these group of packets belong to, let us say, video or mails, etc. Now, after you group it in this way, then you have to associate a user with one of these flows. So, this is a very long process. So, but anyway, unless you have a good understanding of TCP IP suite, you will not be able to do this activity. Okay. So, IP operates at the network layer. Of course, UDP is a connectionless protocol and TCP is a connection oriented protocol. Okay. So, sometimes an IP within IP, that is packets can be tunneled. So, you should also look at how tunneling works, etc. One of the widely used tool, I mean, which we will also see, is the Wireshark tool, okay, which we can show that it puts the Wireshark tool is used to monitor what is happening within the local net. Okay, and similar tools, if it deployed on a router, it will be able to monitor what is happening in all the interfaces. So, it is essentially extension of dumping the packets, whether you are going to dump it in this machine or you are going to dump it in any of the hardware that are shown, or you are going to look at logs. So, there are many ways in which you do it. One is you look at the log files, or you just dump all the packets and then analyze the packets later, etc. We will be looking more closely at the Wireshark tool. Now, I think we have been talking for too long. So, one of the exercises that you could try out is something called virtual private networks. Okay. So, these VPNs are created for security purposes. Okay. So, these VPNs are private networks over the public internet. Now, try to go to the web and take a look at what is VPN, okay, and how security is implemented in a virtual private network. Now, you can also look at what are all the problems a forensic investigator could face when he is trying to analyze someone who is connected through a VPN. So, how do you, one of the first problems is how do you collect a log, because in a VPN there is a end to end encryption between the routers. So, if I am sitting in between, I will be only getting encrypted packets, okay. And VPNs are usually used within an organization to connect organizations that are geographically separated, okay. So, you should look at what are the security mechanisms, then VPN, virtual private network, at what layer, okay, and what are the challenges if someone attacks a network using VPN, that is using VPN, okay. First of all, is it possible? One of the attacks is that if I take away all the links by doing a DOS attack, then VPN will also fail, okay. And you can also find out whether has this happened before, etc. Now, this is for your interest, because hearing too much of theory and then trying to see about a new technology and then trying to study how secure it is or how to break the security in that, that will give you a very, very good perspective of this acquisition as well as the forensic value. We will look at some traffic acquisition software in the next session. Thank you.